I think so. Like I
Hmm.
I know I have learned about them before.
Okay, so do you know about them? Can you tell
Yeah.
me?
Well, like it's when some of the properties are the same,
Hmm.
like and like either so congruent is it like when you can find either like the angle or like a ratio to figure out the side length of a triangle because or is that similar? I think I'm
That's
getting the
similar.
two.
Yes.
Okay, never mind. Sorry.
First of all, let's forget about congruent triangles. Let's try to understand the meaning of the word congruent. Okay, just this word. Because congruent can be anything. Congruent, you could have congruent squares, congruent rectangles. So, in general, what's the meaning of the word congruent?
Same? Equivalent?
Same, or you can say exact replicas, identical. Exact replicas or identicals. So that means any two figures are called congruent if they are exactly same, exact replicas. So here there are two triangles. I copied and pasted the other one. So the point is, if I take the first triangle and I try to put it on the second one, then both of them will superimpose on each other.
Okay.
So that's the meaning of congruent, and any two figures can be congruent. Squares can be congruent, circles can be congruent, trapezoids can be congruent. Okay, so that's the meaning of congruent. But the thing is, now just by looking at these two triangles, can you say that they will be congruent?
No.
No. So in math, we need to prove everything. So just by looking at this figure, we cannot say that they'll be congruent. There could be a slight difference in maybe this side and this side. So unless it's given to us that, so some there are some rules to prove that the triangles can be congruent. So there are about four rules. The first one is called SSS. So SSS means if all the sides of one triangle are congruent to all the sides of another triangle. So if this side is equal to this one is equal to this, and this one is equal to this, right? Then the two triangles will be congruent. Okay.
Okay.
Second one is SAS. Can you guess what will be SAS?
Side angle side.
Side angle side. Yes. Now here, but the catch is that angle, just one thing we have to keep in mind, that the angle that we are talking about, it should be the included angle. So what I mean by included angle, so one side is equal to other side, another side is equal to another side, and then this angle has to be between these two sides. So it has to be between the two sides. Okay, it cannot
Okay.
be like here or here. It, because see, in that's why it's called SAS. You see, A is between the two S's, so the angle has to be between the two sides which are congruent. Okay, then number 3 is called ASA. Okay, ASA is, you can guess.
Um, angle side.
ASA,
Oh,
AS,
angle side angle.
angle, side angle. So this time you will have two angles. So let's say this angle is congruent to this one, this one is congruent to this one, and then again the side has to be the included side. That means it has to lie between these two angles. So it has to be this one, not any other side. Okay, there is one more which is called AAS. In AAS, again you have two angles. Oops, you have two angles, but the side can be any side.
Okay.
Okay, so two angles, any two angles, angle this one, and you can take any other side. Now this time this side is not an included side, so this maybe, and this. And then finally the fifth one is RHS. Have you heard of this one? RHS
Um,
rule?
no, I have not. So this is for right angle triangles?
Yes. Have you heard of hypotenuse leg rule? Hypotenuse leg rule?
No, I have not.
Okay, so RHS, this rule is only applicable in right triangles. So in if you have two right triangles, and so obviously you will have one right angle, so this angle will be congruent. Then if H stands for hypotenuse, so if you see that hypotenuse of both the triangles is also congruent, so hypotenuse is this, if you see hypotenuse is also congruent. And S stands for side, so any other side you take, you can take this one or this one. So let's say this one is congruent to this one. Then we can also say that these two triangles will be congruent by RHS rule. Okay, R stands for right angle, H is for hypotenuse, S stands for side. It's also called hypotenuse leg theorem. Hypotenuse leg theorem.
Okay.
In hypotenuse leg, they have removed the right angle because obviously this theorem is only applicable in right angles. So if in any right triangle, if you see the hypotenuse and one of the legs are congruent, then they will be congruent by hypotenuse leg theorem. They are the same thing. Okay, Nishka, so these are the 5 rules that allow us to prove any two triangles congruent. You will not get a direct question based on this, but you could get an indirect question. Uh, and just
Okay.
one thing, have you heard of CPCTC?
No.
CPCTC means congruent paths of congruent triangles are congruent. So the first letter of each word is C, P, C, T, C. This means that now let's assume that we are able to prove two triangles congruent. We have two triangles and we were able to prove them congruent. Let's say by any rule. Let's say we proved them congruent. Let me give them names: A, B, C, P, Q, R. And it was given to us that this side was equal to this side was equal to this side, and this angle was equal to this angle. So can you tell me, Anushka, by which rule they are congruent?
They're congruent by side angle side.
By side angle side. Yes. Now once you prove them congruent, then all the other parts will be also congruent. Okay?
Okay.
Wait, this is not congruent, this is corresponding
Oh,
paths. So all the corresponding paths, now by corresponding paths I mean this angle and this angle. So these two will be congruent. This angle and this angle will be also congruent. And finally this side and this side will be also congruent. Because obviously now if we have proved them congruent, so obviously they will superimpose on each other. So we can say that all the other corresponding paths will be also congruent. So this is called corresponding paths of congruent triangles are congruent. Okay. Okay, Anishka, now we will start similar triangles.
okay.
Similar triangle is really important. I think I don't need to go over Pythagorean theorem, right?
No.
You
Mhm.
already, yeah, Pythagorean theorem is very basic. Okay, so similar triangles. And Anika, are you familiar with similar triangles?
Um, is it when two like triangles that are like similar, maybe in angles, like, and then you have to like find a ratio to find out like the height
Mm-hmm.
or like the length or
Yeah.
the measurement sides?
And again, yes. Now, first, let's try to understand the meaning of the word similar. And again, any two figures can be similar, not just triangles. Uh, it can be anything similar squares, similar trapezoids, similar circles. So, similar figures are those figures which are, just imagine a figure and you increase that figure by some ratio. For example, what I did here, I first copied this triangle and I pasted it. Right now, when you copy and paste it, they are congruent, they are exact replicas. Now, if I increase or decrease its size in the same ratio, so see, I'm decreasing the size. So all the sides are getting reduced by same amount, or I can also increase its size. So all the sides are getting increased by the same amount. Okay, so when you do this, you get similar triangles. Okay, similarly, you could have similar, let's say, trapezoids. So if let's say this is a trapezoid, now first if I copy and paste it, I've got exact replica of this. So right now these two are congruent because see, I can put it on top of this and it will exactly cover the first trapezoid, right? It will cover the
Yeah.
first trapezoid completely. But now if I increase its size, or I decrease, if I reduce its size, but it should be done in the same amount. So now I am making a similar trapezoid. Okay, so just imagine like the similar figures are the smaller one, it's like the baby of the first one. Okay, now again, how can we prove two triangles as similar? So one thing you should know, Anika, in similar triangles, all the angles will be always congruent. All the angles. So this one is congruent to this. This one will be same as this one. Okay, the angles never change in similar triangles. Okay, so the number one rule to prove any two triangles similar is A, A. Okay, if you see in any two triangles, the three corresponding angles of the first triangle are equal to the three corresponding angles of the other triangles, they will be congruent. Okay. Number 2 is AA. That means even if you have two angles, even if you have two angles which are congruent, even then you can say that the triangles will be similar. And Anika, you're going to get a question like this, that you'll be given two conditions and the question will say which of the following additional condition would be sufficient to prove that the two triangles are similar. Have you encountered such question on diagnostic test?
I think one.
Oh, I think I your voice is not coming properly, Anika. Can you just
Hello?
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 I think your mic is kind of far from your mouth. Can you
Hello?
I can hear you, but it's okay, we can manage. It's okay, we can.
Sorry, Miss Brenda. I don't
No.
know what's going on. Maybe it's my internet
Now it's
connection.
good. Yeah, yeah, now it's good. No, it's not the internet connection, it's the mic, I'm sure.
Oh,
Now I can hear you, Anika. Okay.
okay.
Okay,
Maybe
Anika.
my note is covering the mic and the speaker. So,
Okay. No, I can hear you now. Okay, Anika, so these conditions, so if even if you have two angles which are congruent, even then you can say that the triangles will be similar. Okay. Third one
okay.
is if all the three sides are in proportion. So let's say if this is A, B, C, P, Q, R. Now if I try to find out the ratio of AB, see this is AB, AB over PQ, and the ratio of BC over QR,
Okay.
and the ratio of AC and PR. And if you get these three ratios equal, then also you can say that these two triangles will be similar. Okay, this rule is called SSS, but here the meaning of SSS is that all the three sides are in proportion. Okay, and
Okay.
you would have done this in geometry, right? In high school
Yes.
in geometry, yeah. Okay, and there is a final rule which is SAS. SAS means in this case if you get two ratios equal, so for example if you take ratio of AB and PQ, so AB over PQ, and let's say ratio of AC and PR, okay, and let's say these two ratios are equal and one included angle, so this angle has to be between the sides. So if this angle is congruent to this angle, so if angle A is congruent to angle P, even then you can say that these two triangles will be similar, okay, by the rule SAS. Okay.
Okay.
Okay, so these are similar figures, Anika. Now I'm going to tell you one really important theorem which is asked a lot in the exam. Well, two very important theorems. The first one is if you have any two similar figures, Anika, any two similar figures, I'm gonna write it here. So areas of any two similar figures, it doesn't have to be triangles, it can be any figure. Areas of any two similar figures are in ratio of squares of their sides. What do we mean by this? Let's assume that these two trapezoids are similar, okay? And if any two figures are similar, Anika, then there will be some relationship between their sides, okay? For example, for example, let's say that this is ABCD and this one is PQRS. It kind of looks like that all the sides of trapezoid AB are 2 times the sides of PQRS. Would you agree? That
Yeah.
there would be some relationship always, okay? The sides will be always in proportion. So if there is a ratio of A is to B, A is to B, okay, let's say this is A, this is B. So their sides are in the ratio. What's the ratio of AB and PQ? A over B,
I
right? So
think.
this theorem says that their areas will be, so now if I try to find their areas, area of trapezoid ABCD over area of trapezoid PQRS, then the ratio of their area will be A square over B square. Areas of any two similar figures are in ratio of squares of their sides, okay?
Okay.
And this will work for any figure, not just for trapezoid but for triangles, but for any figure. This is exactly based on this theorem. This says
Okay.
that the trapezoid ABCD is similar to trapezoid PQRS. The length of each side of trapezoid PQRS is 3 times the length of its corresponding side of trapezoid ABCD. The area of trapezoid ABCD is 6 square centimeters. What is the area in square centimeters of trapezoid PQRS? So here we have a trapezoid ABCD, okay, and we
Okay.
have another trapezoid which is PQRS, and PQRS is 3 times, each side of PQRS is 3 times the sides of ABCD, okay? So it's all
Okay.
the sides are. So this means if the length of AB is x, then PQ would be 3x.
Yes.
Okay, and this will be for every side. Okay, if this is y, then this will be 3y. If this is z, then this will be 3z. All the sides are 3 times. Now it says that area of trapezoid ABCD is 6 square centimeters. So ABCD is 6 square centimeters, and we have to find out the area of trapezoid PQRS. So what will be the ratio we just did? Area of ABCD over area of PQRS. Can you tell me what will be this ratio?
So area of A, B, D. So 6 centimeters squared over, right? Or
Mm-hmm.
is that wrong? Um,
Okay.
over PQR and so more.
PQRS. This will be equal to squares.
Well, so what I can't remember what I did.
Okay, wait. Let
Um,
me show. Let me get back to that. See, area of ABCD over area of PQRS is
B squared, like A over B squared.
A square over B square. Ratio of squares of their sides. This is nothing but the ratio. What's the ratio between the two sides? So Anika, what's the ratio in this case of
So in this case, it's like, wait. So 6 squared over, wait.
No, what's the ratio of the sides?
Oh, x squared over 3x squared, right?
Yes, x square over 3x square. Or you could also say the ratio is right now it is 1 is to 3. Okay, you could also write x square, this is also fine. Okay, or you could just write 1 square over 3 square, because ultimately x square will get cancelled. See, now let's try to solve this. So we have to find out the area of PQRS. So 6 over PQRS, x square is x square. What's 3x square?
So 3x squared, 9, well, 9x squared.
9x square. So this x square and x square gets cancelled. So you have 1 over 9. And if you do this, this will also give you 1 over 9. Now can you find out the value of area of PQRS? So you cross multiply. 6 times 9, 54.
Oh, and then just PQRS.
That's the area of PQRS. Okay, so 54 is correct. Okay, anyway, now so this was one very important theorem, Anika, remember this. You can get a question
Okay.
based on this, and you could get trapezoid, you could get triangles, but just remember this one. Okay, now the next theorem, which is the most important theorem, and you'll definitely get a question from this, it is triangle proportionality theorem. Have you heard of this one? Triangle proportionality theorem.
No, I have not.
Okay, so this one says that um, if we have a triangle, let's say A, B, C, and there is a line which is, it could be like this, like touching the two sides and parallel to the third side. Okay,
Okay.
it could be like this as well, right? Touching the two sides and parallel to the third side. Okay, let's go back to the previous one. Okay, let's say you have that we have this side and it is parallel to the third side, and let's call this point D, and let's say this point is E. Now what happens in this case, Anika? Can you see two triangles? One is
Um,
this,
yes. One is like ABC and the other one is ADE. Did I get that?
exactly, exactly. Now what happens is these two triangles are similar. Okay, you can think about why they are similar, but they will be similar. It's very simple. See, this one and this one, they are corresponding angles because this is parallel, right? This one and this one is also corresponding, and this is a common angle. So we get three angles which are same. So the small triangle and the bigger triangle, they are similar. Now a lot of things happen in this case. So first of all, if they are similar, so I can say that the ratio of AB over AD will be equal to, can you tell me the other three ratios?
Uh, so AB over AD will be equal to AD over A. Wait, no, 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 no. Will be equal to AC over
Yeah,
AE, and
AC
then
over
will
AE.
be,
Yeah,
will be equal to BC over DE? Or
BC
is
over
that
D.
wrong?
That's right,
Uh,
BC over DE. Okay, so we're taking the longer side and then the shorter side. Okay, so that's correct. Now, lot of other ratios will be also true. Now see, this ratio BD, just BD, okay, BD over DA will be equal to, can you guess?
Okay, so BD over DA will be equal to CE over EA.
CE over EA, yes. And now another one. I just want to make one change, Anika. Wait, give me a second. I want to change this points A, B, C. Okay. Now tell me what will be the ratios. The first ratio, the longer
Uh,
side and the shorter side.
would it be AC? Wait,
Hmm.
no. AC over
Yeah.
DE
Yeah.
is equal to BA
Hmm.
over BD
Yeah.
is equal to BC over BE.
That's the first ratio, BC over BE. Okay. Then what will happen is even this one, just this portion, dA over this one. Okay. dA over dB. dA over dB will be equal to, can you guess? This one over this one.
Oh, so
Yes,
so
EC
EC over BE.
E. Yes. Okay. Then you will also have the other one is you will also take BD over DE. So I'm taking this one and this one. BD over DE will be equal to, can you guess? Now take the longer one now. BA, BD over DE we have taken, and then it will
So
be equal to BA
D over B. BA over, wait, no, over BC or
BA over
AC?
AC.
AC?
Yes. Okay. Then another one we can take BA over DA. BA over DA will be equal to BC over EC. And finally, on the other side, BE over DE will be equal to BC over AC. These are all the ratios that will be equal, and now in the questions they can give you any one side and they can remove the other side. And see, Anika, you have to understand the logic behind these ratios, otherwise you won't be able to remember all of these ratios, right? These are a lot of ratios. So how do you remember these? By understanding the logic behind them. So you
If,
should be able to write all of these ratios by yourself. Okay. First one
okay.
is very simple. We are simply taking the sides AC over DE. All the three sides we are taking AC over DE, BA over BD, and BC over BE. So we have simply taken all the three sides. Okay. says dA over dB. So now we are not taking the side. Now just assume it to be a trapezoid. So we are taking this side of the trapezoid dA over dB and EC over BE. Okay, so just imagine that this short triangle, this one, is similar to this trapezoid. Okay, so if it's similar to this, then again do the same thing. Sides of trapezoid will be similar to sides of triangle. This side over this side is similar to this side. Okay, now
Okay.
this is done, this is done. Third one is BD. BD over DE. Now we have taken two sides of the triangle. BD over DE is equal to BA over AC. Well, this one is kind of similar to, no, not similar to this one. Now in this one, what we are doing, we are taking the two sides of the first triangle and the two sides of the bigger triangle, right?
Right.
Okay, and you can do the same thing. So this one is done, and in this one, the final one, we are taking BE over DE. Now we are taking the other two sides, so this side and this side, over then the bigger side and the bigger side. Okay, so two shorter sides and two bigger sides, so that's this one. And then BA over DA. Now what we are doing, BA over DA,
Uh,
BA
B
over DA.
A. So A over DA would be equal to,
BA is the
okay,
bigger side,
over
and
the smaller one.
yes, so the bigger triangle will be also congruent to the trapezoid. So the smaller triangle will be congruent to the trapezoid, and the bigger triangle will be also congruent to the trapezoid. So bigger triangle is BA, and side of the trapezoid is DA. Then over here you have the bigger side BC, and side of the trapezoid is EC. And if you take the smaller triangle, then BD over DA. You can even reverse these ratios, okay? So DA over DB, you can also write DB over DA. And the other side will be also reversed then, okay? BE over EC. Okay, Anika, are these ratios clear?
I solve the same thing twice.
This
I think
one, how did you get 83?
okay, for this, maybe it's the same question twice.
So this
Um,
is PV and line segment R. U intersects line segment SX at point W. Okay, the measure of angle SQX. SQX, this one, it's 48. And the measure of SXQ is 86. The measure of angle SWU is 85. And the measure of angle VTU is 162. What is the measure of TUR? TUR, this one. Okay, Anika, how did you do with this? TUR.
I think I accidentally skipped two, and that was the answer to three.
What? Sorry.
I accidentally skipped two, and then carried on to two, three, and stuff.
Oh, you carried. Okay, you went to number 3.
Yes, that was my mistake.
Okay, so you got 83 for number 3 as well, right?
Yes.
So, but this number 2 also you do it. Try it out, okay? Today.
I think I accidentally scrolled, like, skipped the question unintentionally. I
Yeah,
just,
that's okay. No problem. So you got 83 for this one? No,
Yes.
that is not correct. Can you explain how did you do it?
What I did here is I first subtracted 180 from 106,
Okay,
and I got 74.
74. Okay.
I added 74 plus 20. Oh, it's 97. 97. 97 was my answer.
Yeah, 97 is correct. Okay. Okay. Number 4.
D,
Yeah, D is correct. And then number 5.
B,
B is correct. Number 6.
I got 60 degrees.
No, 6G is not correct. Let's
Um,
see.
Q and R.
M, Q, and N R intersect. NP is equal to QP, and MP is equal to PR. Okay. What is the measure in degrees of angle QMR? QMR, this one. So how did you do this one, Anika? You got 6G.
Um, yes. Um, I'm not exactly sure. Maybe I accidentally did QPR or QRP instead. Um, yeah, I think I accidentally said for QRP. So 73.
QRQ?
QRP, angle QRP.
Oh, you got QRP as 60?
Yes.
Okay, so this is 60. We have to find out this one. Let me change it. Let me mark it with. So how can you find out this angle?
Um, so what I do know is that um, uh, MPR will be equal to 120.
Yes, okay. That is correct. This will be 120.
Okay, so that's 51. P, and then I know. Wait, um, I know. Well, isn't there a theorem where if it's like bisecting an angle, or is that wrong?
No, no, there is no bisecting happening here. Now just focus on this triangle, Anika. This one. And if it helps, you can
I
draw it.
so that means M. Oh, because MQ. If MQ are the same, MQ and N are the same. That means PM and PR also have to be the same. So that means their angles must be equivalent as well, right? Like the
Yes.
so that means
So
it'll be 30.
30, yes. So both
Okay.
of them will be 30.
Okay.
Okay, and 30 is the answer. Okay, number 7. This is based on similar triangles.
I got B.
Measure of angle S, measure of angle Q. Let me check. Yeah, B is correct. You got it right. What is the measure of angle ADE? ABC is given. This is a very easy question. In this one, they have given angle ABC is 60 and we want to find out the measure of angle ADE, and they've also given that triangle ABC is similar to triangle ADE. Okay, so this one is very easy. Let's That theorem will also work in this question, Anika. This is not a triangle, but it's a trapezoid. Okay, let's try out this one.
Okay.
In the figure above, AF, BE, and CD are all parallel. So all of these are parallel. So that means we can apply the triangle proportionality theorem. Points B and E lie on AC and FD respectively. If AB is 9, AB is 9, BC is 18.5, FE is 8.5. What is the length of ED? Oh, this is very easy. Can you find out the length of ED?
Okay, so AFB ED should be equal. Wait, if they're all parallel. Wait. Nearest 10th to be less. Um, so 18.5 over 9 is equal to 8.5. Wait, would it be 17.5?
Yes,
Okay.
option B. Okay. Okay, Anika, though, so there will be. Anika, we have not covered one small topic based on triangles, and that is about special triangles. Anyway, we'll do that tomorrow.